Here's a fact that sounds almost impossible. Several large scientific studies have found that people who are completely blind develop cancer significantly less often than people who can see, not slightly less often. In some studies, dramatically less often, with certain cancer types cut by close to half. At first, this sounds like it shouldn't make any sense. Blindness doesn't protect organs, doesn't strengthen the immune system, and doesn't change your genes. So why would something as simple as not being able to see light have any connection at all to your risk of developing cancer? What if it's darkness? The answer, it turns out, has almost nothing to do with vision itself, and everything to do with a hormone you've probably heard of, but likely underestimate: melatonin. And understanding this connection reveals something genuinely useful for anyone who isn't blind too, especially if you're past your 40s or 50s and increasingly aware of just how much daily habits shape long-term health. In this video, I'll walk you through the actual research, explain the science behind why darkness itself may play a protective role in the body, and share practical, realistic ways you can apply this knowledge to your own life, without needing to change anything drastic. The studies that started this conversation. This research isn't new, but it remains one of the more overlooked findings in cancer epidemiology. One of the most cited studies came out of Sweden, where researchers tracked a large cohort of blind and severely visually impaired individuals using National Cancer Registry data. The results showed that people who were completely blind had roughly a 30% lower incidence of cancer overall compared to the general population, and this reduction applied to men and women alike, and was seen in both hormone-related cancers and other cancer types. Here's the detail that really caught researchers' attention. People with severe but partial vision loss did not show nearly the same benefit. Their cancer rates were close to normal. The protective effect appeared strongly concentrated among people with total blindness, meaning no light perception at all, not simply reduced or blurry vision. Separate studies focused specifically on breast cancer found an even more pronounced pattern. Research out of Scandinavia found that blind women had roughly a 1/3 reduction in breast cancer risk compared to sighted women. And notably, women who became totally blind earlier in life, before their mid-60s, showed an even larger reduction. In some analyses, roughly half the risk of sighted women. A separate case control study conducted in the United States found a similarly striking pattern among women with bilateral blindness, reinforcing that this wasn't a one-off finding limited to a single country or population. So this isn't a single small study that happened to produce an unusual result. Multiple research teams, using different populations, different countries, and different cancer registries, kept landing on a similar conclusion: complete blindness, specifically the total absence of light perception, is consistently associated with meaningfully lower cancer rates. It's worth pausing on why researchers found this particular pattern so compelling in the first place. In most areas of cancer research, protective factors tend to involve something a person actively does: eating a certain way, exercising, avoiding a particular substance. This finding was different. It emerged almost by accident, from population health researchers examining registry data for entirely unrelated reasons and stumbling onto a statistical pattern that had no obvious explanation, rooted in behavior or lifestyle differences between blind and sighted people. That unusual origin is part of what pushed scientists to dig deeper into the underlying biology, rather than dismissing it as a fluke. Why would this be true? The melatonin connection. The leading explanation researchers have converged on involves a hormone most people associate only with sleep: melatonin. Melatonin is produced primarily by a small gland deep in the brain called the pineal gland, and its production follows a very specific pattern tied to light and darkness. When your eyes detect light, especially the blue-toned light common in daylight and modern screens, that signal travels to the brain and suppresses melatonin production. When your eyes detect darkness, melatonin production ramps back up. This is the core mechanism behind your body's circadian rhythm, your internal biological clock that governs sleep, hormone release, and many other bodily functions. In people who are totally blind, particularly those without any light perception at all, this suppression signal never happens, because their eyes simply cannot detect light in the first place. As a result, their melatonin production tends to remain robust and largely uninterrupted by external light exposure, even during daytime hours when a sighted person's melatonin would be strongly suppressed. Why would more melatonin translate into less cancer? Laboratory research, including experiments in animal models, has repeatedly shown that melatonin appears to have what scientists call oncostatic properties, meaning it seems to work against the initiation and progression of certain cancers. Proposed mechanisms include melatonin's role as a powerful antioxidant capable of neutralizing cell-damaging free radicals, its influence on regulating cell division and preventing abnormal cell growth, and its interaction with hormone pathways, particularly estrogen signaling, which is relevant to hormone-sensitive cancers like many forms of breast cancer. There's also research showing the reverse pattern reinforces this theory. Studies on melatonin use later in life have found associations with reduced risk of certain cancers, including colorectal cancer, in adults over 50. And separately, people who work rotating night shifts, which chronically disrupts normal melatonin rhythms through irregular light exposure, have been studied extensively for elevated cancer risk, a pattern significant enough that some international health bodies have formally classified night shift work as a probable carcinogen, specifically because of this circadian disruption. Put together, the picture that emerges is this. It's not blindness itself that offers protection. It's the uninterrupted, undisturbed production of melatonin that blindness happens to allow, because sighted people's melatonin is constantly being suppressed and disrupted by exposure to light, especially artificial light, at hours when our bodies evolved to expect darkness. It also helps to understand melatonin isn't just a passive sleep hormone that quietly shuts off once you doze off. Throughout the night, it circulates through the bloodstream and reaches nearly every tissue in the body, not just the brain. Cells throughout the body, including immune cells, appear to have receptors that respond to melatonin, which is part of why researchers suspect its influence extends well beyond sleep regulation into areas like immune surveillance, the body's ongoing process of identifying and eliminating abnormal or potentially cancerous cells before they can grow into a larger problem. Why this matters more than ever today. Here's where this research becomes relevant to literally everyone watching this video, sighted or not. For nearly all of human history, nights were dark. Firelight and candlelight existed, but they were dim and reddish, producing very little of the blue-toned light that most strongly suppresses melatonin. Human melatonin rhythms evolved under those conditions, expecting many consecutive hours of genuine darkness every single night. That environment has changed dramatically, and quite recently in evolutionary terms. Electric lighting, television screens, computer monitors, and especially smartphones and tablets now expose most people to significant amounts of light well into the evening, and often right up until the moment they try to fall asleep. Some researchers estimate that many people in modern, brightly lit environments experience genuine, uninterrupted darkness for only a fraction of the hours their bodies evolved to expect. Some estimates suggest 6 to 7 hours of true melatonin-friendly darkness rather than the 9 or 10 hours common in a world without artificial light. This matters particularly for people in midlife and beyond for a couple of specific reasons. First, natural melatonin production already declines somewhat with age, meaning older adults are working with a smaller baseline reserve of this hormone even before accounting for light exposure disrupting what remains. Second, this is often the stage of life when cancer risk itself begins climbing more steeply due to a combination of accumulated cellular damage and other age-related factors, which means anything that meaningfully influences cancer biology carries proportionally more weight during these decades. To be clear, and this is an important caveat, no serious researcher is suggesting that dim lighting alone prevents cancer, or that bright light alone causes it. Cancer develops through an enormously complex combination of genetics, environmental exposures, immune function, and simple chance. Melatonin and light exposure appear to be one contributing factor among many, not a single master switch. But given how easy and low risk it is to improve your own light exposure patterns, many researchers in this field argue it's a reasonable, low-cost piece of the broader puzzle worth paying attention to. There's an additional wrinkle specific to aging worth mentioning here. As people move into their 50s, 60s, and beyond, sleep patterns often change in ways that compound this issue. Lighter, more fragmented sleep, more frequent nighttime waking, and a tendency to check the time or a phone screen during those wakeful moments, each of which introduces small additional bursts of light exposure precisely when melatonin production should be at its steadiest. None of these habits are anyone's fault. They're simply common patterns that tend to emerge with age, but recognizing them is the first step toward gently working around them. What can you actually do with this information? You obviously don't need to, and shouldn't try to, replicate blindness to gain any theoretical benefit here, but there are genuinely practical, gentle steps that align with what this research suggests about supporting your body's natural melatonin rhythm. Step 1. Protect the last hour or two before bed. The single most impactful change many sleep researchers recommend is reducing exposure to bright light, and particularly blue-toned light from screens, in the 1 to 2 hours before you intend to sleep. This doesn't necessarily mean eliminating television or reading in the evening entirely. Simple adjustments like dimming household lights in the evening, switching phone and tablet screens to a warmer color setting many devices now offer, or simply holding devices a bit further from your face and keeping brightness low, can meaningfully reduce the light signal reaching your eyes during the hours your body is trying to ramp up melatonin production. For anyone who reads before bed, warm, dim reading lamps tend to be far gentler on evening melatonin production than the cooler, bluish overhead lighting common in many homes. Some people also find that switching to a physical book instead of a backlit tablet in the final half hour before sleep makes a noticeable difference in how quickly and easily they fall asleep, even if it feels like a small change at first. Step 2. Make your bedroom genuinely dark. Even small amounts of light during actual sleep, a street light through thin curtains, a glowing alarm clock display, a hallway light under the door, can interfere with melatonin production throughout the night. Blackout curtains, an eye mask, or simply covering small electronic light sources with tape are inexpensive, one-time fixes that many people underestimate the impact of. This is a particularly easy win because it requires no ongoing behavior change once it's set up. Step 3. Get genuine bright light exposure during the day, especially morning. This might sound contradictory, but it's actually a key part of the same system. A strong, well-regulated circadian rhythm depends on clear contrast between day and night. Bright light exposure during daytime hours, especially within the first hour or two after waking, helps anchor your internal clock and actually strengthens your body's ability to produce melatonin robustly once darkness arrives. A short walk outside in the morning, or simply sitting near a bright window with your morning coffee, does more for this than most people realize. Step 4. Be thoughtful about late evening habits that quietly involve a lot of light. Many people don't think of certain evening habits as involving significant light exposure, but a brightly lit kitchen while preparing a late dinner, scrolling through a phone in bed, or falling asleep with the television on can all meaningfully disrupt the natural darkness window your body is expecting. Being aware of these small, easily overlooked sources adds up over the course of consistent nightly habits. Step 5. Talk to your doctor before considering melatonin supplements. Given the research connecting melatonin to cancer risk reduction in certain populations, some people wonder whether taking melatonin supplements might offer similar benefits. This is genuinely worth discussing with a healthcare provider rather than deciding on your own, particularly for older adults who may be taking other medications, since melatonin can interact with certain drugs and its long-term supplemental use for this specific purpose isn't yet as well studied as the research on natural, endogenous melatonin from light regulation. An important caveat. It's worth being honest about the limits of this research before wrapping up. Several of the specific studies involving blind populations relied on relatively small sample sizes, particularly the totally blind subgroups, since total blindness is relatively uncommon. Smaller sample sizes mean wider statistical uncertainty, and researchers themselves have noted that factors other than melatonin exposure might also be contributing to the pattern observed, even if melatonin remains the leading and most consistently supported explanation. It's also worth remembering that this entire body of research describes an association, not unquestionable proof of direct cause and effect in every case. Blind populations may differ from sighted populations in other ways that weren't fully accounted for in every study, and untangling correlation from causation in population-level research like this is always genuinely difficult. None of this means the findings should be dismissed. The consistency of the pattern across multiple independent studies, combined with a plausible, well-supported biological mechanism involving melatonin's known effects on cell division and hormone regulation, makes this a genuinely credible area of ongoing research. But it's reasonable to hold the specific numbers, a 30% reduction here, a 50% reduction there, with some appropriate scientific caution, rather than treating them as precisely established facts. It's also worth adding that no researcher in this field is suggesting light exposure is anywhere near as significant a cancer risk factor as things like tobacco use, or that fixing your evening lighting habits should replace standard cancer screening and medical checkups. This research is best understood as one additional, genuinely low-cost piece of a much larger picture, not a replacement for anything your doctor already recommends. Closing. To bring this all together, research spanning multiple countries has consistently found that totally blind individuals who experience no light-driven suppression of melatonin develop cancer meaningfully less often than sighted individuals. The leading explanation involves melatonin's documented role in fighting oxidative damage, regulating cell growth, and interacting with hormone pathways connected to certain cancers. You don't need to be blind, and you certainly shouldn't try to simulate blindness, to potentially benefit from this same underlying biology. Simply protecting your evenings from excessive light, keeping your bedroom genuinely dark at night, and getting good bright light exposure during the day are small, low-cost habits that align your own body more closely with the natural darkness rhythm your melatonin system evolved to expect. What makes this particular piece of research so compelling isn't that it hands us a miracle cure. It doesn't. It's that it points to something almost entirely free, requiring no medication, no equipment, and no drastic lifestyle overhaul. Simply respecting the natural rhythm of light and darkness your body has relied on for essentially all of human history, long before electric light existed at all. If you found this video interesting, please consider subscribing and leaving a like. It genuinely helps this kind of research reach more people. I'll see you in the next video. Until then, take care of yourself, and maybe dim the lights a little earlier tonight.